Hello, everyone, and welcome to the Secure Developer. I'm Sam, for those of you who don't know me, and I'm the community manager here at the TSD. And I'm joined today by Matt Raible and Simon Maple to talk to you about 10 ways to secure your Spring Boot application. So really excited to have them here. But before I hand over to them, just a few sort of housekeeping things. If you aren't on the Slack channel yet, it's the best place to ask questions. So if you're watching this from the TSD website, just scroll down to the bottom and there's a link. Otherwise, if you jump onto thesecuredeveloper.com, there'll be a link to the Slack. And if you join live sessions, you can ask those questions. If you're not watching us live and you're watching us after, you can still jump onto that and ask the questions, and we can facilitate those back to the speakers. So please keep those questions coming, even post-event. And last but not least, if you just go to the cog on the bottom of your screen, if you click that and up your resolution, it's the best way to view today. We're supported by Sneak. They are the company behind this. We're really happy to have them involved. But as I said, it is a vendor-neutral community and about application security. I hope you enjoy it. So that's enough from me. I'm going to hand over to Matt and Simon. Over to you guys.
All right.
Thank you very much.
Let me share my screen here. Hopefully we'll get the Inception kind of view going. Okay, can you see my slides?
Yep, looks good.
All right, so this presentation is 10 excellent ways to secure your Spring Boot application. And Simon and I actually wrote this, or a blog post about it, way back in July of last year. But the good news is everything's actually stayed up to date, and there hasn't been a whole lot of new activity in this space, so these recommendations are still very relevant. And we also have a link at the bottom to the blog post there, and so we'll begin.
Do you remember where we wrote this, Matt?
Yeah, we wrote it at JCrete.
This is one of the hardest conferences to get your company to pay for, to get you to go, because you say, I'm going to go to Crete for a week and learn some stuff, but there's no schedule. And I don't know who's really going to be there, but please pay for me to go. And it's actually an amazing conference.
Right, and it's just it's an awesome environment because first of all, you're in Crete, it's warm and beautiful, and second of all, there's tons of really knowledgeable people there. And I think Simon and I actually wrote this blog post in just a few hours, so it was one of my most productive moments. So you can always go to your company with that and say, hey, I heard that Matt Raible is really productive at JCrete, so maybe I can be too.
I also wrote an amazing cheat sheet on the beach, looking over the beautiful Cretan waters with the current chairman of Maven, Robert Schulte. So yeah, absolutely go there. Not for the beaches, but obviously for the great content.
Right, for the productivity. So the first one is might be somewhat obvious, but it is use HTTPS in production, and you might know this as SSL. But SSL is actually the deprecated name. TLS is the official name for HTTPS. It's called Transport Layer Security. And it's basically a cryptographic protocol that provides secure communication over a computer network. Its primary goal is to ensure privacy and data integrity between computer applications. So obviously a good thing to have. And as of July 24, 2018, just a week before Simon and I published our original post, Google Chrome now labels HTTP sites as not secure, so it actually shows up in the browser address bar. And so we basically recommend use HTTPS everywhere. And a lot of the reason for this is because Let's Encrypt offers the free HTTPS certificates. It's no longer a pain in the butt or a costly thing to actually get SSL certificates. It used to be something that you had to pay hundreds of dollars for, and if you wanted a wildcard certificate, it was thousands of dollars. So you can use CertBot to generate certificates. You can use MakeCert, which is a project on GitHub that allows you to create localhost certificates, and it works really nicely. A lot of times it's a pain to do localhost certificates because they don't add them to your keychain. Your browser shows an error, so with MakeCert, it actually gets around that. And then there's also a Spring Boot Starter, Acme project, that automates the getting of certificates. So Acme stands for Automatic Certificate Management Environment. Let's Encrypt supports that, and you can basically have a cron job that gets you new certificates all the time. And so to force HTTPS with Spring Security, it's actually pretty easy. Spring Security is obviously the default security mechanism in Spring Boot. You can configure it like this. If you extend Web Security Configure Adapter, and you just say, hey, it requires this channel, and it requires secure for any request. So that's great, but if you're in development, you might not want to use HTTPS because you didn't want to install MakeCert or something like that. So another way to do it is just to do it for production. So if you're using something like Heroku or Cloud Foundry or most other cloud providers, they'll have an exported proto header that you can read, and if that exists, then you'll require secure. So you can still use, HTTP in development and HTTPS in production.
Awesome. And if we hop over to my screen now, I'm going to share as well. And hopefully you can see the main screen. We're going to be telling you 10 tips to basically prevent people hacking from your sites. And that kind of seems a little bit, hard on the attackers, because we're taking these wonderful hacks away from them. So what we're also going to offer you is a number of life hacks in return. So Matt, when you have kids, you really want night lights, right? To stop them being scared at night, right? Because, when kids wake up and they're there at night, when it's pitch black, it can be a little bit scary for them. So here's a good life hack for you, Matt. When you have old kind of like dolls or old teddies and things like that, and rather than just throw them away, one thing you can do is if you take their head off, you can put a light bulb in the head and make an amazing nightlight. And a nightlight like this isn't just free, but it'll also prevent your children from being scared at night. How good is that?
That's great. So you have young children, is that correct?
I do. I have a 3-year-old and I have a 7-year-old, and this works just fine for them.
So I think they would love it. And I have teenagers that actually have a dark side, so I think they would like it.
Perfect. Yeah. There we go. So there's the first life hack. Now we're going to go over to the ways you can actually remove the hacks from your environment. So we're going to talk about scanning your dependencies for vulnerabilities. And of course, this is made no more clear than the Equifax breach, which happened not too long ago, actually, in fact, back in 2017. Now, this has obviously made headlines and everyone knows about this, and it actually sparked a lot of companies' interest in the fact that they need to protect themselves to prevent them being breached like this as well. But I don't want to talk about the company necessarily. I want to talk about the packages, the libraries, the frameworks, the dependencies essentially that are behind the scenes, behind the websites that were actually hacked in the first place. And in the case of Equifax, this was done with the Java Struts 2 vulnerability, or Java Struts dependency, which had a vulnerability in it. Now, when we think about your application, how your application is composed, your code is actually very, very small. Your application is very large, the application you deploy. So the code you write in your browser, in your IDE, can just be a short number of lines, but you only need to pull in a small number of dependencies and then have your transitive dependencies being pulled in before your application is very, very large. So Matt, I'm gonna ask you a couple of questions here with this serverless example. There's just 19 lines of code, right? And this is a small application that will fetch and store a file into Amazon's S3. How's your Node these days, Matt? I think this is Node. I'm not sure. Maybe JavaScript.
I've got some knowledge. Yeah,
you got some knowledge, right? So 2 direct dependencies that we have here in this file that you can see at the very top on the left. How many indirect dependencies, transitive dependencies, do you reckon we're going to have in here?
I'm going to go with 4,000. 4,000,
right? I didn't realize you were so knowledgeable about NPM, actually. Do you know, there's the other day as well, NPM reached the 1 million package mark for 1 million index packages. That's pretty insane. But this one, just shy of 4,000, 19 dependencies in total. So 19 lines of code, 19 dependencies. Do you have any idea, Matt, how many lines of code we're actually going to be shipping here?
Well, I've run count lines of code, CLOC, on many Node projects, and boy, it's a lot. So I'm going to go with, let's say, 200,000.
Bang on, pretty much. 200,000 lines of code. That was an amazing guess. So what we're actually looking at here is 19 lines of code that a developer sees, but almost 200,000 lines of code that is deployed. And where we think about the vulnerabilities that are going to exist, they exist both in directs and indirects, of course, but mostly in indirects, because the dependency tree that exists behind that is going to be much, much greater. So what I want to do is I want to show you a very quick demo. I'm a developer advocate for SNCC myself, so the demo I'm going to use is going to be using SNCC, but of course there are other tools that you can use as well that do this just as easily. I'm not going to show you anything which is paid service. Everything I show you is going to be entirely free on a freemium tier that you can use today. So I'm going to go across to my browser. Here I am logged in with into the SNCC site at snic.io. I've logged in with my GitHub credentials, so I can click on GitHub here. I'm going to open up one of my repositories in GitHub, and the repository I'm going to open here is, let's say, zip-slip goof. Now this is a nice repo because it actually has the name of the vulnerability in the repo name itself, which is kind of nice. What this is going to do is it's going to import this, and in fact it's already done this. I can view this project and I can see not only the dependency tree that is behind this application, and this includes direct dependencies like Spring Boot, and also the vulnerabilities that exist in the transitive. So I can see some like Hibernate and some like Aspect J and other things like that. If I wanted to go to my issues, I can see more information and more detail about each of these. And even this is, for example, a zip-slip vulnerability. I can even fix this just by clicking through and then pushing my pull request for this specific vulnerability back to GitHub. So I import it through GitHub and I can push the fix, the automatic remediation back to GitHub. What this is going to do is it's going to pull us up to the minimum version that you require, so from 1.12 up to 1.13. Now, when we think about vulnerabilities and what vulnerabilities you can expose, I'm going to show you one vulnerability in an application that we have here. This is just going to be a Spring Goof application. This is a Spring Boot application. It's a grocery list essentially, and it has a repository. So this is going to be using Spring data. And I can show you a couple of other files here. We have an item. This is my domain object, which is a grocery item. And I can also show you the repository, which is just a basic CRUD repository. For those of you who are familiar with Spring data, you'll recognize this. But what I'm actually exposing as well is this repository REST resource. So this is exposing my data, my domain object and models with RESTful APIs. So if I come here, I can actually say, let's go to my items API, and I can see some information here. So we can get beans at 50p, milk at $1.09, and so forth. If I wanted to, as this is just JSON, I can look at one specific version of that. Now, with this API, with this RESTful API, what I'm going to do now is I'm just going to send a quick curl, and this curl is going to use Spring, the SPEL, Spring Execution Expression Language, under the covers. And what it's going to do is it's going to exploit a vulnerability called Spring Break by grabbing the runtime, by executing with that runtime the etc, a cat of the etc password, and then grabbing the output stream and sending that back to my console. And I'm just going to be hitting this one API here. As soon as I hit that, you can see all of a sudden we've got an exploit, and this is the etc password on file here. So that was one example of an exploit. And of course, with this exploit, the simplest way of trying to fix this is by moving up to a version of your dependency that has the fix for that runtime. So let's talk about how we can upgrade to latest releases as well, because what I showed you is using a tool that will allow you to move up to the closest release to the one you are on to avoid vulnerabilities in your current versions. Another way of doing something like this is to upgrade to the latest releases and try and maintain being on that latest release. Now, if you was to go to start.spring.io, Josh Long's second favorite place on the internet apart from production, you can see that you can essentially create your application here. And what this will do is it will put you on the latest versions of not just your direct dependencies, but the transitive dependencies that get pulled in as well. So as soon as you create your application, you know you're going to be on the latest versions. So the question is then, how do you stay in the latest versions? And also, how well do you know your dependency? If there are downstream transitive vulnerabilities, how well do you know your direct dependencies are going to be pulling in the fixed version of your transitive? So it's very important to understand the health of your dependencies and how often they update. So there are a few things here we can look at. We can look at, if you're using npm, for example, you can use the npm check updates command, which will look at the node modules that you have and see what versions you're currently running and what is the latest version. Very, very similar with Maven here, using the display dependency updates, and also with Raible as well. You can see which versions you are currently running and which versions you need to jump up to. So that's the way of keeping up to date. Sometimes that's not possible, and it's better to switch to a model whereby you upgrade just when you need to with security. For some newer apps that you're updating quite regularly, this is more of a possibility for you. So, Matt, let's talk about what happens when you've either got a lovely loaf of bread or you've got maybe a bagel or something like that. You're trying to cut it in half. You're trying to cut it bang on so that it's completely level. Then you hate it when it's at an angle, right? Now,
oh, yeah.
Well, I can imagine. With bagels, you know, bagels come with this amazing life hack that they come with this area that you can actually stabilize the whole bagel as you cut it. So, you know, with this hole, you can cut your bagel completely flat every single time. You will never have a slanted bagel. Amazing life hack. Typically work once or twice before you realize perhaps a better way. But this is an amazing life hack, Matt. You tell me how that goes.
All right. My son loves bagels, so I'll have to try that next week. All right, back to me. Let's see. Make sure I'm screen sharing here. Ooh, don't give it away. Okay, so you might have heard of CSRF. That stands for cross-site request forgery, and it's basically an attack where a user can execute unwanted actions in an application they're logged into. This typically happens by using like an embedded GIF or something like that, and getting a cookie from a site, and then using that cookie to actually send back the request and do bad things to your application. So if the user is a normal user, a successful attack can involve like state changing requests, like transferring funds or maybe changing their email address, which obviously can be dangerous. And if the user has elevated permissions, a CSRF attack can compromise the entire application. So a lot of people think that, CSRF isn't a big deal. Like, so what? I would like to introduce my dog to you. His name is Sagan, and he's a border collie, so he wants me to throw the Frisbee right now. Usually I'm working here all the day and it's quiet and he doesn't even care, but as soon as I start talking, he's into it. So if I locked him out of the room, he would be scratching at the door. So sorry for the barks every once in a while. He's kind of like a CSRF attack happening right now. But basically, the bad thing that can happen with CSRF, like imagine if someone actually gets your email address and changes your email address. Most people think like, what's the big deal? Like, but if they go to your bank and they put in that email address and they say, forgot password, and it sends it to that one, then they can get your bank, and then boy, that's a big deal because they can get all your funds. So with Spring Boot and Spring Security, there is a way to actually do it, and Spring Security actually has CSRF support on by default. So if you don't want it, you have to do http.csrf.disable. And then if you're using Spring MVC's form tag or time leaf and enable web security, it'll automatically be added as a hidden input field. And if you're using a JavaScript framework like React or Angular, you'll actually have to do a little more work. So this shows what that looks like. You'll have a token repository, and then you'll set that it's with HTTP only is false, because HTTP only is true is on by default. And if you're using a JavaScript application, you want to be able to read the cookie and then send it back as a header. So if you're using Angular and you specify this in your Spring security configuration, everything will happen automatically. Like, it's smart enough to read an XSRF token cookie and send it back as an XSRF token header. If you're using React, you have to do a little bit of that work yourself, but that's all that works. The other thing that is probably one of the best things you can do is a content security policy. So what I found is a lot of developers don't know about this, and you can actually do a lot of this work at your web server. So you don't actually need to do it on your actual application. You can do it at the web server level. So a content security policy is an added layer of security that basically mitigates cross-site scripting and data injection attacks. So what you can do with a content security policy is say, hey, only these websites can actually have scripts that load into my site. And so you can just have your scripts, for instance. The other thing that I've seen is every application is secure until it goes to production and marketing gets involved. So that's one thing to be aware of. The default Spring Security headers that are sent are these ones. So you can see cache control expires security transport and X-frame options and all that. And then if you want to do CSP in your actual Spring Boot application, here's how you might do that. You can say script source self. So if there's any scripts that come from this application, those are fine. And then if you want to embed Twitter or something like that, then you would have to have those as well. And once you've done that, you can verify it with securityheaders.com, which is a website that'll actually go through and see all your different headers and if they're set properly, and if you have a content security policy as part of that. And then we wrote a blog post, or a colleague of mine did, on how to have better website security and how to get, you know, an A+ rating on those security headers. So you can see this is actually from his site, and he started out with a D. And so that's pretty neat. Now we have another life hack.
You absolutely have another life hack. So, Matt, are you a coffee drinker or a tea drinker?
I actually like them both, but I've been drinking more tea lately.
Okay, right. So, what do you do, Matt, if you want a cup of tea, want a cup of coffee, but all the mugs are completely used?
Use a beer mug?
That's a good one. I've got a better one for you there, Matt. Rather than use a beer mug, then you'll have more to wash up, right? This is kind of like peppermint tea. Let me share my screen and I'll show you what I'm talking about. So the worst thing for me, and this is great for students as well, of course, when we have hopefully you can see my screen now. Hopefully, right. So when we have a cup of tea or when we have a coffee that we want to make and we don't have this cup, the best thing we can do is, rather than have peppermint tea, have pepper tea. Okay, so what we have here is a nice cup of tea that we can enjoy, plus you can eat the cup afterwards, and it's very, very healthy for you. So this is a great life hack, saves you time, doesn't make you wash up, plus it gives you something, probably one of your 5 a day afterwards. So great life hack for you there.
And if you like spicy tea, then it works great, right?
Oh, exactly. You can have a chili pepper as well, and that's a shorter, like a shot of tea maybe for the smaller ones. But and this is like for a bell pepper, it's kind of like a longer drink. So you got choices, of course. So number 6, this is back to you, right, Matt?
Yep. OpenID Connect is a great way to do authentication. And for me, it was one of those things where I was a consultant for 20 years before I joined Okta, which obviously has OpenID Connect as one of our products. And I would often develop applications that just had the users in the application, and it wasn't a big deal. And, you know, I worked for many corporations that did this. And what I realized was, as an enterprise architect, what you really want to do is share your users. And you don't really want to have each application deal with passwords or user management or anything like that. So OpenID Connect kind of adds that ability. And how it works and how it came about was, it started with, I don't know if you used Yelp.com or maybe, you know, LinkedIn.com way back in 2005, but they used to actually prompt you to put in like your Gmail username and password. And if you did that, then basically they would have your password, and then they would use it to get your contact information and do all kinds of stuff like that, and spam all your, you know, contacts. And so OpenID Connect came about to actually allow you to redirect to a provider like Gmail that has your information, and then give someone permission to get to your contacts. And so this is how the whole flow looks. But if you use like sign in with Facebook or sign in with Google, you've used OpenID Connect. And you might have heard the more familiar term called OAuth 2. And OAuth 2 does the same thing, but it doesn't include any identity information. So there's no way of telling who the user is. All you know is that they have access to data. And so OpenID Connect basically makes that very easy. It was developed by Google and Microsoft and many of the big players to actually allow this type of thing. And anyone can use it. The cool thing as a developer is if you're coding to it, then it'll work with any provider. So you could use Google, you could use Okta, you could use Facebook, and you're not really tying your code to any particular provider. So with Spring Security, they've added OIDC support in 5.1, and you can see what the configuration looks like here. You'll basically register it with a company like Okta or GitHub, and from that you'll get a client ID and a client secret. And so what we call identity providers is kind of like the DMV for your car. If you take your car in and get a new license plate, this is the same sort of thing where you need to register your application. And then you'll have an issuer URL that gets all the information for the specific endpoints that Spring Security needs to talk to. And so I'm going to do a quick demo and just show you how this code works here. So I'll go to my IDE.
Did you notice earlier that as soon as you said Yelp, your dog barked? That's pretty.
He's a fan, right?
Yeah, right.
Right. So here's a simple application. So let me full screen this. And I don't know if any of you used SDK Man, but SDK Man allows you to basically pick your Java versions. So we have Java 12, we have Java 11, all these different things. If I look at my current Java version, I'm using Java 12. And so it also allows you to install Spring Boot. And with Spring Boot, you can actually run scripts like this. So this uses Grab from the Groovy community to pull in the Spring Boot Starter OAuth 2 client. We create a REST controller, and then we print out the user's name. So if I do spring run hello.groovy, it'll start it up and pull in all of Spring Boot, and I didn't even need to write a pom.xml or a Gradle file. And so once that's up and running, I can open up the browser. See, we'll try Safari here. Oh, I got the full screen going, so it's not going to let me. Hold on. So we do localhost 8080. And it'll basically redirect me to Okta since I configured that. And then I log in and it comes back. And you'll see it says hello to that strange number. And so I also printed out the user here that comes from the Java security principle. And you'll notice it has a whole bunch of other information in it, like preferred username and name right here, but it's in a user attributes clause. So if I do user.user, I think it's user attributes. Well, the cool thing is you can actually look it up on this class right here, this OAuth 2 authentication token. So this is what Spring Security is implementing that principle with. So if we look at that, we can see that it's got a get principle. And then if we get that principle, it's an OAuth 2 user, and then that has the attributes. So we'll go ahead and say user principle attributes name. Let's try that. So we will have to restart the server. And then it's implementing and using single sign-on, so I never signed out. So I just refresh, and it's going to talk to the server and come back and give me my proper name. So it's a great way to get identity information from Spring Security. And you'll notice this is all I need to configure for Okta. I did go and register that before this session, but it's pretty easy to do. You just create a new application, you select type of web, you give it a name, and then it spits out all this information for you, the client ID and the client secret. And if you want to use Okta's plugin, there's also a different starter you can use and a more concise bit of configuration. So we also do audience validation when we do that, and we do some more groups mapping for the granted authorities that Spring Security doesn't do by default. So this also works with Spring WebFlux. The configuration doesn't change a whole lot at all. So if you've ever used Spring WebFlux, you can use it with OpenID Connect. And just to let you know, there is an actual issue with Spring Security 5.1 with refresh tokens, but it only exists with Spring MVC. So if you're using Spring WebFlux, the refresh tokens will happen automatically. There's access tokens and refresh tokens in OpenID Connect and OAuth, and refresh tokens are used to get new access tokens. So access tokens typically only last, a minute, 5 minutes, maybe an hour, and refresh tokens last days and weeks. And so with the refresh token, Spring Security will automatically get you a new access token if your access token's expired. But just so you know, that's not quite implemented in Spring Security 5.1. It will be in 5.2. And it also works with JHipster. So I coded all the OpenID Connect support in JHipster. It works with Keycloak by default, and you can switch it to Okta just by changing a few properties. You could probably switch to another OpenID Connect provider as well. So back to you, Simon.
Okay, and actually before we jump forward a little bit further, we've got a few questions. So some questions from some of the earlier points. Pavel Palmer asks, I'm curious if we recommend check HTTP in Spring or on the web server like Nginx or Apache above the application, the Java application or servlet container. So would you say one or the other, or perhaps both?
Obviously, if you can do both, that's going to be the most secure. But people used to be worried about HTTPS actually slowing things down, and I don't believe that's as true anymore because computers have gotten so fast. But absolutely, if you have a web server in front of your Spring Security server, you can do it there as well. But if there's a loophole and they can get around that web server and still into your application, then you're going to want that secure.
Awesome. And another question from Manfred. Can Spring Boot CSRF security work without a session?
I'm going to say no, but that's a guess. Okay. I'm not quite sure.
This is like Who Wants to Be a Millionaire? So how confident are you, Matt? Would you say 60%, 90%?
I'm gonna go 80%. The 80%. Other thing that is kind of related is JOT authentication or JWT authentication. People think that, hey, I can use Spring Boot and I can use JOT authentication, and now my application doesn't require state. And this is true, but now you're putting a lot of information and all that session handling that used to work for you by default into a JWT, and you're kind of managing that yourself. So I do have a colleague, Randall Deggs, that argues against JWTs for session management and just use whatever session management you already have. JWTs are great, but they shouldn't be used for session management. So it's similar in the sense of if you really want to scale, typically sessions aren't really your problem. It's probably the session implementation. And Spring has a Spring session project that actually does a lot to get around that, or you can use Redis for a cache for your session cache. And there's great ways to scale and still use sessions.
Okay, awesome. Right, so we're going to jump forward. Hopefully, you're seeing my screen now. We're going to talk about managing passwords. So, if you have an application whereby you need to do any password manipulation, you really need to use password hashing. There's not even a question about this. You need to be using password hashing. So, what is hashing? Well, it's the ability to when you have a string password to convert it into an unreadable string, so that if someone does hack you, or when someone hacks you, the set of characters that you have stored, someone's secret, is impossible to read in a way that they can actually use those characters to log in as you. It's also impossible to convert back, and these are what is known as hashes. So the flow that someone would go through as they go to your site will be, for the first time, they would obviously create an account. They would pass an account. They would pass a username and a password. Now the password that is taken will be hashed. And that hashed password would then be stored. The password which is going to be sent in the plain text password, as it were, that should never hit the disk. There should never be any persistence of any plain text password on your site. So the next time that a user attempts to log in, they will pass in their password again, and the same hash process will occur. And it's the hashed password which is checked against the hash password which we have stored. Now, if those two hashes are the same, then you'll log in. Everything will be good. If those are not the same, then you'll go through your normal error handling and send someone to ask maybe a couple more times to log in. That's what password hashing is. So what are the rules of password hashing? Well, first of all, they need to be deterministic, obviously, because if you hash the first time, you want, if you get given the same password, to provide the same hash for that password, so that you can actually then you can compare it against your stored hashed version. So as many times as you hash the secure developer here, TSD, you should get the same hash value. And irrespective of how long the string is that we're trying to hash, you're going to get the same length hash for that. So it's deterministic. Plus, one of the things it should be is one way. So in other words, if you have a string that we're going to hash, that'll get you to your hashed value, but you can't unhash back to your original password. It's a one-way function. As a result, if someone were to get the hashes or a list of hashes, the way that they would actually try and work out which password was stored in that hash would to be to try and hash normal plain text to try and get to a state which you have matches to that hash in your stored database. Now, obviously, that can be, depending on which hashing algorithms you're going to be using, that can be easier or harder. There are also things like salting, which will allow you to pass in random strings to your password before hashing, and it gives you extra additional layers or that will actually allow you to make it harder for someone to work out what they are. But it's a one-way function. You get to a hash, you can't go back to the original value. And if someone, for example, you see on Twitter all the time a number of people who call out companies for sending them back their password. They should never have that. The only way they would have your password in the clear is if they're storing it in the clear. If someone has taken a hash from you, they can't give you your password back, because not even they can go from that hash back to the original password. It shouldn't also be predictable. And what I mean by this is, here we have 4 hashes, TSD 0, 1, 2, and 3. They are completely different, even though the difference in the text, in the actual password which we're pushing in here, is just altering that 4th character. They're completely different. They're not virtually the same, and then we just change the last few characters. So they're completely non-predictable. And then the other thing is, obviously, we need a one-to-one mapping. So if we have a first hash, which gives us a hashed value back, we can't hash another password and get to that same hash. They are unique mappings between one password and one hash. So what does this mean to Spring? We have our Spring application. What we can do is we have these encoders that exist in Spring that we can make use of. Here, what we're doing is we're just creating a Spring bean around a password encoder, and as part of that password encoder, we determine what kind of encoding we want. And in this case, we're using bcrypt. I think in the original blog, some of the members of the cryptography team in Okta suggest also using scrypt for passwords. I think that was one of the recommended ways, and you can also do that with Spring. But here we just have this bean, and with this bean now, of course, we can inject into a regular field our password encoder. And now at this point, we simply just need to encode using that password encoder whatever string we have, and that will provide us with an encoded string afterwards. So this is a very, very easy way with annotations in our own code. We can hash passwords, and as a result, we never store that plain text password. We only ever stored that hashed value.
And actually, Spring Boot makes it so you have to specify some sort of hashing algorithm.
Right. Yeah.
If you specify like in a properties file or anything like that.
Mm-hmm. Yeah. Good addition. So let's move on to another life hack. Now, Matt, don't you just hate it when you're inviting people around? Your friends have got an awesome pasta holder, right?
Right.
This is we are in the 21st century now. People have these first world problems about what pasta holder to have. How about this? This is a pasta holder which is going to change every single time someone comes around to your house, and it's going to surprise any visitor, even Italians who have seen all pasta holders. Now, this pasta holder, not only will you enjoy the pasta, but it's a great game actually trying to find where your pasta is in the kitchen at that very point. This is one of the most exciting things that your dinner guests will ever have. Great pasta holder. And also, if you ever buy too much pasta, then this great pasta holder is just the perfect shape to eat that pasta, eat any pasta that you have cooked too much, which is a great thing as well, right? How good's that?
And it looks adjustable in size, so if you have just a little bit or a lot, it can, kind of conform.
Absolutely, yeah. And you can actually buy these pasta holders in different sizes. And obviously, as your family grows, the pasta holder will naturally grow in length as well. So you can, there are extremely large pasta holders you can buy in this range. So definitely a good life hack there.
Nice.
So let's talk about secrets. And secrets is. This is one of the things that, with the tools we have and the speed at which we can start pushing not just code to repositories, but, pushing things to production, it's very easy to slip our secrets. Now, if we go to GitHub and just do a simple view, and you can see on the top left here, I've just searched for removed password. One of the things we see a couple of things here. First of all, we see 335,000 commits, whereby people in their commit messages have actually said that they are removing a password. Now, that's pretty good because from an attacker's point of view, because guess what? One of the great things that GitHub and Git has is this wonderful commit history that'll show us the changes that have been made to files. And when you change passwords and things like that, guess what? We can see the new password. We can see the old password. And you know, this is one of the things that not only is it crazy that we can see this many, but there's also a number of people who have changed secrets who haven't been as blatant in the commit message. So, you know, there is an extreme amount of sensitive data in the wild, which is very accessible using some of the development tools, which make our development easier as well. Now, there are tools that can help us with this, and tools that can help us automatically as well. And the first one I'm going to show you here is something called Git Secrets. Now, Git Secrets actually prevents you by checking things like your commits and things like that. It looks for patterns. It looks for credentials. It looks for passwords, those kind of things. And you can get it to block your commits based on whether it thinks it has found secrets or not. So this is a great way of actually auditing, you know, checking on every commit and so forth, our code. There are also other things like there's another one called Git Rob, and I think there's Git Truffle as well, which are great ways whereby you can download your entire, clone your entire Git repo, run it across your Git repo. It'll look at your code, it'll look at all your previous commits and so forth. So there are some great tools out there which you can audit your code bases and find secrets that you can remove. And remember, when you remove secrets, make sure you entirely burn those secrets and also update your commit histories. Now, when we're thinking about what we do in code, we can of course use vaults, and of course HashiCorp have great vaults as well. But we're going to talk about Spring Vault here, which actually backs HashiVault is in the background as well. So Spring Vault here. We just add it as a dependency, and as a result, we can actually then start accessing it via annotations again, simply by passing in a value here, and it'll automatically inject the values from the vault into our password. So we don't necessarily need any significant secrets in code and things like that, because it's all later done at runtime. So secrets, very, very easy to leak into our existing developer tools, very easy to leak into production. Make sure you use vaults, make sure you use tools during your commits, during your very, very early stages, to make sure you never actually push those secrets anywhere in which people can access them. So moving on to testing your applications with OWASP Zap, and this is over to you, Matt.
So you actually pointed out an anti-pattern in my last OIDC mechanism, because I am actually using secrets in my code. So if we looked at the code here, you'll see I have an Okta OAuth 2 issuer and the client ID and the client secret. The client ID is like a license plate number. It's not a big deal, but the client secret kind of is. So I'm actually showing a bad practice here. But one of the things that I would recommend, for instance, if you're using the Okta starter instead of the Spring Boot one, is you can actually do things like Okta OAuth 2, right, issuer or client secret, like that, and then run like Spring. You'd set it to, you know, foo, and then run Spring run hello. Or if you're doing MVN or Gradle or anything like that, you can do it the same way, or you can set them as environment variables, and then you won't actually be storing them in source control. So that's one of the things that we do with JHipster. We use Keycloak by default, and they're just, you know, easy passwords to guess. But then when we actually recommend using Okta, we tell people that, hey, you might want to actually use these as environment variables. Don't actually store them in your source code, but store the Keycloak ones in there because everyone's using those, and it's not a big deal. It's just a demo. So OWASP Zap is a security tool that performs penetration testing against your live application at runtime. So it's very popular. It's got over 5,000 stars on GitHub, and it's open source, and it basically has two approaches. So you can do a spider scan or an active scan. So with a spider scan, you basically give it a seed of URLs, and an active scan actually records a session and plays it back, scanning for known vulnerabilities. So this is a result of a scan that I did way back 8 years ago on, I think it wasn't a Spring Boot app, but it was a Spring app. Might have been my AppFuse project, but it showed a number of vulnerabilities that could happen, and also gives you ways to actually shut those down. So The cool thing about the active scan is typically what you do is you fire up a web browser and you point it to, I think it's port 9000, and that's where OWASP Z attack proxy or ZAP has a proxy running to record everything. So you do a session, you log in, and so it's going to know your username and password, obviously, which is good for it to know, because if it can't log in, then there's not that much it can really test. So it logs in and it does a whole bunch of stuff with your forms. It tries to input all kinds of invalid data and do script attacks and SQL injection and things like that, and then it spits out a report at the end. So very nice to use. I wrote a blog post on it, but I'm not going to share it here because that's way back in 2011 that I did it. But I haven't tried it on any new modern apps that use like an Angular front end or a React front end, but I imagine it would work just as well, because a lot of it's on the back end in the sense of, it can hit a URL and see all the files in a directory and things like that. And that's not really going to happen so much on the front end. But, HTTP only flags for cookies are going to be very important, and, not doing password auto completion. So you can learn more about it on its website, which obviously that URL isn't great. So just Google OWASP ZAP. It's also on GitHub, and there's a project on Twitter that you can follow. So boiling water, I think I saw this one. This is one of my favorites.
So yeah, this is a really important one, actually, and one that a lot of people can learn from. So Matt, we've already talked about the pasta, right? We now have seen our guests the amazement on their face at this amazing pasta holder. Some of them may have even got close enough to measure the amount of pasta they want. We don't want to leave them hanging. We don't want to leave them in a state where they have to then wait for the host to cook their dinner for 30 minutes, 40 minutes. We want to be able to entertain them. So the last thing we want to do is spend a lot of time boiling water for our pasta. Now, this is an amazing life hack, because what we can do here is we can save a lot of time by boiling our water in advance. Okay, and obviously to keep that fresh, we can put it in the freezer, and then all we need to do is just simply reheat this water as and when our guests come around. So as you can see here, I've got loads of boiling water all ready just to use straight away for my guests. It'll leave them thinking, how have you cooked this pasta so quick? So Matt, this is an amazing life hack that we both need to really do more of.
It's probably good for like students in the university too, because they'll believe it.
Yeah. What do you mean? You mean this isn't a life hack?
Been doing that for years.
All right. Okay. Cool. Me too. Okay. That was our last life hack. Some of you may be very pleased to hear. We're also going to show you our last tip as to how you can make your applications more secure. And this is really a good housekeeping tip. And I think when we do code reviews, there's a big correlation between the size, the amount of code you're pushing into your commits, and the number of comments that you'll actually get back. If it's a small code review, then everyone will be arguing about a comment or about the naming of your method. If it's a code review where someone's pushed in about 100 files, most likely you'll get very, very few comments. Maybe a couple of people will just say, yeah, this looks good to me, within 2 minutes of you asking for an approval. So what do we need to do in our code reviews to actually perform a security code review? One thing that I would say is you should recognize and understand which files, which specific areas of your application are very sensitive to security issues. And as a result, make sure that you have the right people, when changes are made to these files, have the right people look at the changes to those files for code reviews. For general developers doing code reviews, I think there are a whole bunch of different tips that we can provide, or at least different areas that we need to look at to make sure that we're not making basic mistakes. So, a number of these, I'm not going to go through every single one of these, but this is a nice list. And in fact, I'm going to, this is going to be my top 10. I'm going to be doing a cheat sheet soon. So do check out the SNCC blog for more information on these, but I can go through a couple of them. First of all, and this is probably one of the most important, is around validating third-party input. And this is important because we basically need to make sure that we don't trust anyone. Don't even think about the golden path. Think about an attacker doing something, passing you information that you don't expect. What's your code going to do? This is really, really important, making sure that we understand what is third-party data, what is third-party input, and also then making sure we validate correctly. We've talked about not storing credentials as code config, but this is a good one to review in code review as well. We've talked about number 3 as well, making sure we don't introduce new vulnerabilities. And with security vulnerabilities, when we pull everything down to a level whereby our application has a baseline or a snapshot of security vulnerabilities that we are not comfortable necessarily, but that we know exist, and that we've done risk assessments on that, the biggest thing that we need to do is make sure we don't regress. So commit by commit, pull request by pull request. How do we make sure we don't pull in new vulnerabilities or new license issues? And using SNCC or other tools, this is a great way of being able to automate that. Authentication, and also enforcing least privilege. So making sure people aren't just authenticated on inbound requests, but are authorized, and using the least privilege. In other words, when you have users, make sure that you give them just the information, just the access and the privileges they require to do what they need to do. That's very, very important as well. A couple of others, obviously, we have handling sensitive data. So, what do we do with that? How do we store it? Make sure we don't log things. Make sure if we're transmitting, do it, in a secure way. One other thing here is about protecting against well-known attacks. Well-known attacks like cross-site scripting, for example. We know the type of characters with cross-site scripting that we need to avoid. For example, angle, brackets, ampersand, single quote, double quote. We need to make sure that that we exclude these kind of characters, or even better, whitelist which characters we will accept as input. This comes down to, again, validating third-party input. And of course, statically testing as well, statically testing your own source code as well as the dependencies that are coming in. So making sure you don't introduce security vulnerabilities into your code. Of course, there are tools as well that you can do that and automate that on pull requests, automate that on commits as well. You will likely get more false positives in this kind of area, but it's definitely an area that we need to spend time on as well. And that's it, Matt. We've done all 10.
Right. So that's the summary of everything. I do have a couple bonus ones though. So not only don't allow your lack of security to be disturbing, but my company actually has a great T-shirt that says I find your lack of security disturbing. So these are great to wear in airports. If you travel a lot, TSA gives you a smirk every once in a while. I recently traveled to Barcelona last week, and no one even smiled. So sometimes they just don't get it. But
Matt, have you ever been to Israel?
I have not.
Right. So people in security airports in Israel, I'll tell you now, this is a good an additional, a bonus life hack. They have the most amazing sense of humor. So when you next go to Israel through security lines, do make sure that you wear this shirt.
I have a feeling that's a bad idea, but hey, I'll do it anyway. For a good story. I also wanted to point out the thing we didn't mention was this cheat sheet that Simon made, which is based on our blog post, and same thing as this presentation. So if you want it just in a PDF that you can hang on your wall, print out, this will give you a great way to do that. And otherwise, thanks for attending. Follow us on Twitter, SJMaple and Raible. We'll upload this presentation probably to the secure developer, so you'll be able to download it there. And now we'll take any additional questions.
Awesome. So we have one from Sanu saying, what do you mean by identify and validate third party? Do you mean need to understand what is using it or something else? So what I'm really talking about here, let me unshare my screen. So what I'm talking about here really is when we think about as an application, we have information or input that is coming in from perhaps other services, from our own processes, as well as things that come in from a user or another service, which is a third-party service to us. And as soon as we get any information, either from a third-party service or an end user, we have to treat that information, that input, that text, whatever it is, that file, as suspicious information. We have to test it. We have to validate that it exists within the boundaries of data that we require for our application. Let me give you an example. If I were to, and this is actually a zip slip example, If we have time, I can maybe do a demo. But if I am an application that takes a zip file as an input, and I extract that zip file, there is nothing stopping me. In fact, let me. If I share my screen, I can do a see how quick I can do this demo. In this zip file, let me see where this zip file exists. It's probably going to be in here. No, it's not. Wow, this idea of a demo seems such a good idea at the time, Matt. Okay, in here, if I was to jar -tvf the zip slip .zip file, this is just this could be an input from a third party developer, right? If I was to run that, you get two files. You get a good.txt, which can be expanded, extracted, and it will exist in the file that my application wants to put it in. This could be a public directory, for example. However, my second file has a whole bunch of directory traversal. So what this file actually will do, and this is an example hack that will work on Heroku. It'll go right back to my root directory, and it'll drop this native to ASCII JDK script. It'll overwrite this native to ASCII JDK script, and if I just cat this, you'll actually just see it's just a gotcha text. But when if I didn't validate this third-party input that there is no directory traversal, for example, here, then I'm just treating this user input as good input. And this is where potential security issues occur. So in code reviews, and this is just the same for if we take input from a website, for example, and we're running this, executing some SQL. How do we know we're not doing SQL injection? How do we know there's going to be no cross-site scripting and stuff like that? So whenever we look at any kind of third-party input from a user, from an external service, for example, make sure we check that it's in the right format, and there is no chance that someone, or we limit the chances that someone can potentially be use that in a dangerous way to us.
And I would say that in the Java community, we can probably do better. I have heard .NET Core actually does validation by default. For instance, HTML characters and stuff like that, and strips them out. You have to turn it off. And you can do that with Spring MVC and its validation techniques, but not by default, right? So
yeah,
I think
it very much depends. I think Python does this. Python does this by default as well with the directory traversal on a zip file. Actually, it was the SNCC security team that found this to be very, very prominent across Java, and one of the reasons is because there isn't a Java. There aren't some libraries, some core libraries that do a lot of these basic functions for us. So you end up with developers writing this by themselves and actually not validating what comes through.
Right.
I don't think there's any other questions, Sam.
No, I think that's it. So thank you, both of you, very, very much for getting involved. If no one learns anything about securing Spring Boot, I think the life hacks alone are, ones to live by. I always have a problem with the hot water, so definitely going to do that when I get home.
And the dolls lights, are simply wonderful for a child to wake up to.
I've actually got my sister visiting with her kids soon, so definitely going to get one of those.
That'll really surprise them.
But thank you both. Hopefully we will have you both on here again. As both Simon and Matt mentioned, in a few minutes this will be live on the website under past sessions, so you can go back, rewatch, share with your friends. If you've got any more questions, post them on the Slack. We'll get them answered for you. Both Simon and Matt are Slack members. And then on the 20th of June is our next event, and it's going to be the new ways of DevSecOps with James Wickett. So please join us for that. All the information is on thesecuredeveloper.com. But other than that, that's all from me. I hope you enjoyed it, and hopefully we'll see you again soon. And thank you, both of you, again.
Thank you very much.
Cheers.